Hello everybody, this is Mr. Longo, and in this video we are going to cover overlapping triangles. I'm going to warn you, this is a little bit tricky. And the reason why is because if you look at this diagram closely, there are three right triangles there. Not one, not two, but three. Because if you look closely, we have a right triangle right here. We also have another little one next to it. But if you look at the big triangle together, there's a third. So whenever that happens, meaning you have a right triangle with an altitude dropped from the right angle, you're going to have three similar triangles. Let me show you how we come up with the similarity part first. We're going to pretend, this is not always true, but we're going to pretend that this angle A is 30 degrees. If we work in this side, because this is 90, this has no choice but to be 60, because triangles must add up to 180. If this top angle is 90 degrees, and this part is 60, this guy's got to be 30. Which means this guy down here has to be 60. So you will see that this angle is going to be congruent to that angle up here, and this top angle on this triangle is going to be congruent to the bottom one down there. Now, what if we were to get rid of that altitude? If we were to make that go away, we still have a 30, 60, 90 right triangle. Okay? So that's how you look at all of them. Now I'm going to make those angles go away, and I'm going to come up with something that might help you a little bit. What I would recommend you do is maybe put an X on the congruent ones, and then maybe an O on another congruent one. Okay? And what we're going to do is draw all three of these right triangles with that pattern, where we have like a right angle down here, maybe our O at the top, and our X in the bottom. Again, the X's and O's mean nothing except for the congruent angles, or the ones that correspond with one another. So the first thing I'm going to do is look at just the triangle on the right. If we looked at the triangle on the right, we have the O at the top. That corresponds with C. And then we have the right angle as D. And then finally we have X is A. And if we look at our variables, we have a B, a Z, and a Y. And now I'm going to switch over to the other, one of the other triangles. We'll go with this guy on the left now. Now you have to be careful. We're looking at the X. So X is now our C. So C is now over here. Our right angle is D. And then our O is B. Being able to redraw these is going to prove to be very helpful. Finally, the last one is the big triangle altogether. The big right triangle ABC. C is our right angle. A is X. And B is O. And then again, like we just got done doing with the other ones, it's kind of helpful to put down your variables as well. So for this guy over here, we know that BD is X. We know that BC is A. And we know that CD is Z. And then for the big triangle, this guy over here, BC is A. This is C. And this is B. Now, I spent so much time talking about that because when we get to examples that look like this, you're going to need to know how to set those up. And a very important skill to have is to be able to redraw the three triangles and put the right information where it belongs. Okay, so we're going to go down here and work with one of these examples. So again, I am just going to put an X, an O, X, and an O just for redrawing purposes. So if I went with OX, 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 if we look at this triangle on the right first, we know that this is 6, and we know that this is 9. If we look at the triangle over here, we have O to the right angle is X, and then X to the right angle is 6. And you should see that we actually already have enough information to do this, but we'll go one more, and the big one, opposite of the X, we have nothing. Opposite of the O, we have nothing. And then on our hypotenuse, we actually have X plus 9. Now you can assign letters A, B, C, and D like we did in the original. Now remember, the X's and O's inside here mean absolutely nothing in terms of variables. But now, since we know about similar triangles, we can just do 6 over X is equal to 9 over 6. Or 6 over 9 is equal to X over 6. Either way, it's going to work out. But the interesting thing that's going to happen when we work with these right triangles with an altitude is 2 of the numbers are almost always going to be the same in terms of your pictures. So this, again, 6 over X equals 9 over 6. And these two are going to cross multiply and a lot of times be the exact same. And that's going to be called a geometric mean. So we would just cross multiply and solve this, and we're going to get X is equal to 4. Okay? That is how you do this using similar triangles. But now I'm going to go back up here and teach you another way to do it, and it's called using the geometric mean. A geometric mean between A and B would be solved something like this. A over X equals X over B, where the mean is going to be the same, kind of like what I talked about down below. So I'm going to teach you a little trick here. What we're going to do is try to solve this using geometric means. So we're just going to copy this guy, and we're going to talk about him down here. But I'm going to get rid of the letters A, B, and C, and D. And we're just going to use this. So you see how this C represents this entire side length? We're going to write him off to the side. And the reason why we're putting him on both sides is we're going to draw a little mountain now. We're going to draw 3 mountains. And we're going to make it look like this. We're going to draw a line from C to A to X, X to Z, Z to Y, Y to B, and B to C. And the trick is that the top of the mountain is the geometric mean of the 2 bases. So, as you can see, we have C and X are the bases of A. So we would have C over A equals A over X. Z is the top of the 2 bases, X and Y. So another one of our geometric means would be X over Z equals Z over Y. And your last one would be over here to the right. We would have Y over B equals B over C. Now notice how I put my geometric mean in the same place So the top of the mountain is in the mean positions. So if you use that, it could help you solve questions like this as well. Okay, so I'm going to get rid of this one because he wasn't used in the first problem anyway. And you can use that strategy here. So we know that this base is 4 plus 5. We know that the whole length of it is 9. The whole length of that is 9. So if we were to connect our mountains, boom, boom, we would see that 9 and 4 are the bases and x is the top. So we can just do 9 over x is equal to x over 4. And then you would just cross multiply, so x squared is equal to 36. Square root both sides and you get x is equal to 6. That's it. You're done. If we were to go back to this question that we were just talking about, if you know how to accurately draw that mountain, that would be off to the side to here, down, here, down, here, down. Look, 6 was the geometric mean between x and 9. So we could have done this one as x over 6 equals 6 over 9. See, those guys are the same. We would get 9x is equal to 36. So x is still equal to 4. Now, why did I show you where it comes from in the first place? Because this is a unit on similar triangles. And we needed to show you where everything comes, because you might be asked to redraw all 3 similar triangles and list the ratios. So now you know how to do that. The X's and O's trick is a little tip for that. However, you can use the geometric mean, this guy down here, for a shortcut when you're solving for x and y. Okay, that's it for this video. This is Longo and I'm out. See you, bye.